Yes, recording.
Yes. So our first problem is like maximum profit in job scheduling. So n jobs are given where every job is scheduled from, the given start time and the end time. During that, you'll obtain a profit of I. And given the start and end time and the profit arrays, we need to output the maximum profit, which can be done such that no two jobs in the subset should overlap with each other. So if you choose a job that ends with X, you'll start only that starts at the time X. Like first job starts from 1 to 3, so 50, and other is 3 to 6, so they are non-overlapping, so 50 plus 70 is 120. And coming to second, if we go by the greedy, we like to pick 100, so we won't be able to maximize our profit because most of them will overlap. But if we go 20, 70 and 60, we'll have 150. So this is our, what do you say, maximum profit. Yeah. And here like 1 to 3 I'm choosing. Because we can't choose 4 and 5 because they are overlapping. Yeah.
Okay, so when they are overlapping,
Yeah.
all of them, as in the example, last third one, right?
Yeah.
So then you just look for whatever is the maximum profit.
In them, yeah. Because only one I have to pick out of them.
Mm-hmm.
And your constraint is 10 raised to the power 9, so definitely n square won't work here, right?
Or n log n may not work too.
N log n will work, yes.
Oh, Leon, did you say it won't work? N log n2?
Yeah,
No.
may not because it 10 to the 9.
No,
Yeah,
n log
because yesterday someone was saying, right, it's 10 raised to 8. So then be careful. Yeah.
I think this is for the individual time. Number of objects is still 10 raised to 4, right?
Yeah, but
Oh,
that,
yeah. Sorry, yeah.
the
Because start time and end time is
mapping.
that, right? Yeah, makes sense.
Still, if your n time is bigger, that will be counted, right?
No, actually, it should be the length of
N
the
to the
profit.
4.
Yeah. Okay.
Yeah, I think we will do big O of length of number of jobs instead of big O of time.
Correct. Okay, you only mentioned that, Johan, right? Yesterday.
No,
No, it was actually not me.
It was
somebody else who is also new over here.
Oh, okay, no problem. Yeah. So yeah, so it might be the length of the profit start because 10 raised to 4, right? That much processing we'll have to do.
So it won't affect the individual time.
Okay, sorry. Let's come back. What was the question, Shashank?
I'm saying it won't affect the individual time. I mean, this time the time length is like it is going to 10 raised to the power 9. It will also affect your performance, right? Not only the length.
But that is the value, right?
Yeah.
The one what you are underlining. If you look at that, yeah, that's the value, no? So you are saying if you use that value, will that affect?
We need to also look for potential overflow of an integer, right? Because 10 to the 4, is it? If we keep adding, it might overflow.
Well, if you add, so you will add only in the case of profit. You're not going to do any additions and anything on start time and end time.
Yeah.
Yeah. Let's say you have 10 to the 4 array of 10 to the 4, and each of the profit is 10. Each of the profit is 10 to the 4, right? So you have to multiply them 10 to the 4 times 10 to the 4. Yeah, I think it's fine. It might not overflow. Okay.
Yeah.
But what would be the brute force?
Brute force, like, I mean, for every time slot you check, right? And make sure that start of one should not be before the end of other, just to avoid the overlapping.
Yeah, the brute force with like you always, let's say you pick an index of the job, and you always say, okay, this is I want the max profit where this always be the first profit. The given index is the first profit for the job.
Okay.
So, for example, you pick first job is profit, 50. What the best profit you can you can get? If the first profit is is 50, right?
Yeah.
Correct. Mm-hmm.
How do you take care of overflow in brute force? Overflow, nahi, matlab, what I'm saying is overlap.
Overlap, right? Yeah.
Yeah.
So one way I look at it, and slightly extending what Leon was saying. Okay,
Yeah.
so if we just take the example one, and so if we are given this 4 jobs, so I'll do exactly the way it's shown in the figure. What I'll do is I'll start with one job, okay, whatever is in the list, and start forming a sequence of all the jobs which are not overlapping. Okay, and so that will be my starting point. Okay, and I'll add all the profits. I'll say this is my profit. Okay, so then whatever the intervals which are left over, okay, then I will start comparing them with the overlaps, and wherever there is overlap, I'll see if that can fit in between the two, like in this case 10, right?
Yeah.
So if I have this 10, I'll go there, I'll pick up this one, and this 10, okay, if I'll just compare, if it is, if I replace this 50 and 70 with 10, will I get a better profit? Okay, so if I get, then it is fine, I'll replace it, or I will just reject it. Then I'll do the same thing for 40. So it means what I'll do is I'll have a visited array, something like that. Okay, and for
Yeah.
each and every array, whenever I'm consuming them, I'll just put in state saying, okay, it is visited. And when it's not, then I will go in the visitor array again, find out whichever are the uh, those slots which are not visited. Okay, and I'll do overlap and try to see if they fit. If they fit, then I'll replace them. Okay, so that will be a very brute force.
Yeah.
Mm. So even let's say in this case, if we take the profit 50, we have two non-overlap, right? The profit 40 and profit 70. Then like we have to consider each of them, right? And recursively. Because the first profit we get a 50, now you can either take 40 or take 70.
40 you can't take, right? Because you'll have to compare 50's end time with the 40's start time.
That's allowed. Yeah. So you can take 50 plus 40, your profit will be 90, right?
No, but 40 is overlapping, right?
No, he's saying don't use 70. Instead of 70, you can take 40. 50 and
But
40, they are not overlapping.
50 and 40. Okay, it's starting at 3 only. Okay,
Yeah,
sorry.
it's starting at 3.
Yeah, go ahead. Sorry.
Yeah. Problem. So then you want to do it recursively, you are saying, right?
Yeah.
Yeah. Okay.
So it's like a tree, where the root could be 50, and then we have two branches. One is 40, the other one is 70. And we have to, go to each branches. Go to each branch and find the max profit.
Okay.
Yeah.
And then you are going to sort the whole list.
Yeah, have to
okay.
sort it, right?
Yeah. So based on what? Start time?
End time also. Okay.
End time. Okay.
Okay. Yeah. I thought sorting on end time should work, because if we have end time, start time we already know, right? And so it will be easier to compare end time of one with the start time of other.
Okay. Yeah, that is a good one. But okay, if we do sorting on end time,
Mhm.
so what benefit you really get? I was not.
If we sort it on end time, right?
Mhm.
So one thing I got, again and again, I won't be visiting that the what do you say, the end start and end time, like to check which one is overlapping or not.
Okay. If you are an end time, okay. So
Because yeah, go ahead.
if we take this example, the one to the first one, okay, and then we just walk through in this case, right? So
Yeah,
in this case, now the end time is 50 is the first one, right?
50, yeah, 3, yeah.
So 50 is the first, then our 10 is the second, correct? And
mm, 40 is
it-
third.
yeah, 40 is third, right? And then you have 70, which is 4. Okay, so now if you go that way, so you'll pick 50, correct? The first one, because its
Yeah,
ends time is 3. And then what are you going to do in this case? Because there is nothing to check in that case, correct?
then I'll check 10's start time and 40's end time. Sorry, 50's end time.
Okay.
So as you can see, that 10's start time is less than the end time of 50. So that will cause an overlap, right? So I'll
Mhm.
ignore that. Then I'll go for 40. Now 40's end time and both are
Yeah.
equal. So, yeah, yeah,
Before going there, sorry to interrupt you. When
yeah,
you
sure.
said this 50, you are comparing this end time with the start time of 2, right? You
Yeah.
see that this is smaller and therefore we find it is an overlap. That's correct.
Skip. Yeah.
Okay, but if it is an overlap and in this case the profit was more than 50, so would you
Oh,
still not take that?
yeah, that's true. Then you'll have to sort it based on all the three, right? I mean,
Oh no,
first
I'm
priority.
just asking. So yeah, let's go with your method. Sorry. Okay. I don't want to interrupt you. Go ahead. So you
No,
said
no.
first we do
Mhm.
50, it's not overlapping. So we ignore 10 for now. Okay.
Yeah.
That is the second one. And then what do we do with the next one?
Next you'll pick 40, right? And 40 is a start and end time is matching with them.
Uh-huh.
So 50 plus 40, it will be 90, right? And you will
Okay.
keep on updating the max, like whatever max, till now max is 90, right?
Okay. Uh-huh.
Now the only you are left with the last one, only 70.
Okay.
And 70's end time is 3.
70 m time is 6. Okay.
Okay, end time is 6. Yeah.
Yeah.
Sorry, what is start time of 73?
It is 3. Yeah. So then you look for again the overlaps.
Yeah, again it will be overlap, right?
So you have all the overlaps, right? Okay. In this case, then also it is greater than 40. So you can replace that with 70.
70, yeah.
Yeah, then you remove 40 from that 90 and then add 70.
70 to that, yeah.
Yeah, if you had a bigger interval, with many samples, then
That will
it
be
would
more
be
good.
clear, right? Yeah, okay, makes sense.
Actually, they are following this knapsack way, what I like saw in the discussion in this.
Really? Okay.
Yeah, like if they include it, then what is the profit? And like what we do in Kadhane's algorithm, previous sum array, sub array sum is going on, right? From
Mm-hmm.
back, it's coming. Now, when you add current element to it, what is the profit? And if I don't add my current element, what is the profit? Max of those two they are taking. So same thing they are doing here.
So they actually sorting on the start time, the way Leon was saying.
No, they were sorting on end time.
Oh, really? Okay.
First priority was end time, and if there is a tie, then they will go to start, and if there is a tie on start, then they will go for profit.
I think it will depend on whether we are doing a prefix DP or a suffix DP. If it is a suffix DP, we can sort on end time, and then DP of I is equal to maximum profit from ith element onwards. But if we are sorting by end time, we have to do a prefix dp, where dp of I is equal to maximum profit up to ith element.
I minus 1, no? Or I.
Yes, one of that. I actually did a suffix dp, so I sorted by start.
Oh, okay. Okay, that's interesting. So you can actually do it. So when you say suffix and prefix dp, do you mean to say you are adding the profits in your dp array, right? In the prefix or suffix way?
Yes, I'm filling the dp array backwards, and I'm saying dp of I is equal to maximum profit starting the job at ith element.
Okay. Yeah.
Yeah, then.
So the way you are describing, Shashank, it was a prefix dp, right?
Prefix, yeah.
Okay, yeah, and he is doing it. Okay, good.
So when you say like a snap sack is like you at the you have two profit. You take one profit is 40, the other is 70, right?
Yeah.
Either you take 40 or
Or
you don't
70.
take 40.
Before taking that, you just check with if both of them are not overlapping. That means both of them are potential candidate, right?
Yeah, so I see. So if there's more profit that start at 3, then you also check that profit too.
3, yeah.
Okay.
But in the knapsack way, you will have to check for each and every slot, right? Or you are actually comparing the overflows first?
No, first I compare over it, because if it is overlapping, then there is
Sorry,
no point
overlapping.
overlapping. Then there is no point in taking that, right? Because that will contradict.
Okay.
So first I filter those candidates which we can add, and depending on that, then we will check which will fetch me the max one.
Okay.
Kind of, yeah. Not exactly knapsack, but somewhat at the higher level.
Right,
Like,
right, yeah.
Yeah,
It's
I
the
also
recursive
thought
way.
in a similar way. If I'm taking the ith element, then I
okay.
want to find the start time at ith element's end time and take dp of that start time, that time.
Okay.
dp
Would
of
you
my
want
end
to,
time.
would you like to annotate and explain it here?
Yeah, it will be more better.
I can share my screen and
Sure,
try
sure.
to explain them
Okay, no problem.
at
Yeah, go
the
ahead.
time.
Go
Yeah,
ahead.
go ahead, Ivan. It's 1235. 1235 number. Yeah.
So first, what I thought was dp of I basically tells me dp of I tells me that if I select ith job, then what is the max profit? So if I select ith job, that means from so first of all I take profit of I and I add remaining jobs, remaining whatever array is there, remaining suffix, since I'm thinking backwards. So I take all the remaining jobs and I add the best dp answer of the remaining. Now the question is, how do I find this remaining? So what I did was, first I sorted all of them by start time. So this is just the Python code for sorting by start time after I made the jobs array. And now I just made one dp empty array. So I'm doing this job, right? Ith job. So I'm traveling backwards. I'm doing the ith job. So what is the remaining job? So if you notice in this diagram here, if I am doing this profit equal to 10 job, remaining jobs are only those that are starting after 4. So dp of 4. So dp of 2 will be equal to 10 plus dp of 4, which is 0 over here. But the actual answer will come out here. dp of 3 will be profit 70 plus starting at 6, which is 0, since that's a base case type. And now when I see this job, dp of 2 is 10 plus dp of 4. Is the suffix idea clear? Like basically from here onwards.
Okay, but you cannot take 40 in that case, right? When you are considering 10.
Yes, so here I have to see this, both of these jobs will be seen. And since this 40 and 70, 70 is a higher number, so 70 would be selected.
Oh, okay, okay. So you'll pick up the 70 you're saying, okay.
Yes, and now especially when I come to the first index, so dp of 1 is equal to 50 plus dp of 3, which is 70. So that's the answer. So what I'm doing here is just a upper bound, or a lower bound actually. On my current end time, next job should start at that time. At my current end time, the next job should start at that time. So I just take the max of my current dp. So this would have erased the 40 when the 70 came. I take the max of the current profit I can get by not doing this job. I plus 1 means I am not doing this job. I'm doing the next job. So at 1, I'm not doing 1, I'm doing dp of 2. And basically doing this job, that is taking the profit and taking dp of the remaining suffix. So if I do a dry run here, what will happen is, first of all the jobs will get sorted by their start time over here. So I have job 1 for 50, job 2 for 10, job 3 for 40, and job 3 for 70. Initially, the DP array, I have just put a random size of 2n to allow for this upper bound. I could just put n plus 1 also, I think. So first we go to the last element, dp of 3. dp of 3 is equal to max of dp of 4. Basically, all is coming afterwards. And otherwise, we are doing the job at index 3. So if we do this job over here, end is equal to 6. So it is profit equals to 70 plus dp of end, dp of 6.
Okay, the next one.
Yes, then I go for the next dp of 3, but here this answer will not get updated. Then I go for dp of 1. That time what happens, it is max of dp of 2 and profit, which is equal to 50 plus dp of remaining. Now when will the remaining start? Remaining will start when I end, which is at 3. So basically this was the suffix logic which I used.
Okay, makes sense. Okay, yeah.
Can you please control? Can you show that example again? Like that was very interesting and very useful.
Okay.
Oh yeah, that's it.
So
That's
the
it.
basic idea is I'm doing backwards.
No, I got the. I just wanted the snapshot, so I got the snapshot.
Yes.
Thanks. I'm good. Thank you.
Yeah,
It was awesome.
Like 3.
Awesome.
What is 3? 3 is the end time.
3 is the start
Job
time.
number.
Oh,
Starting
that's
time 3. So
It's
3
not
could be the, actually you could think it's the third element in jobs array. Since my n is jobs, so third element in jobs array would be first element, second element, third element, fourth element. So index 3 is the fourth element.
Okay. So when it tie, they both at 3, then you sort it by the end time.
I sorted by start time over here. Since when I find my current end time, I want to find the remaining jobs that will start after this job. So I want to do log n or find on start.
No, but if 2 start times are same, then how do you break that tie?
You do binary.
Over here, right?
Yeah.
So the thing is that this profit is equal to 50. Actually, I wrote this wrong. 0, 1, 2, and this will be 3. Start equals to 3, end equals to 6. Here also start equals to 3, end equals to 6. So now DP of 2, when we check, it will actually take max of 70, which is this one, or 40 plus DP of 4. So this 40 will get ignored actually, because DP of I plus 1 is greater. So it will ignore job number 2. This is case for ignore. This is case for take current profit. But if you take current profit, then the remaining suffix is only after your end time. So it's better to ignore because 70 is greater than 40 plus 0.
Interesting. Yeah. This is very good. Yeah. So it was slightly hard to follow, but you made it very, very easy now.
Yeah,
Yes,
you made it very easy. Yeah.
Right.
Yeah, exactly. Yeah, it was awesome.
Yeah.
So these are all the indexes of the elements. I by mistake wrote that time that it's the time.
Yeah, that's fine. Yeah.
Yeah.
Okay, so you don't really have to do any overlap checks over here because you
Yes.
actually go to the end, always. Okay, the
Yes,
end time, and therefore.
either you take the current element or you don't take it.
Makes sense.
Just the knapsack, normal knapsack. Take, don't take.
And if you don't take, then you take the DP of the remaining one along.
Yeah, you take DP at the next suffix, immediate next suffix.
So as you are just using the max, okay, it's doing it internally the knapsack, right? So we
Yes.
don't have to bother.
Yes, yes. We are not worrying about like this 40 got skipped because DP of 2 starting at the second elements better to take from 3 only. 70 is greater than 40 plus 0. So we don't take this element. Then DP of 1 again 10 plus the next remaining elements, we don't take it. And here we take it and we get the correct answer.
Yeah. So this, the time complexity is n log n.
Yes, for finding the remaining suffix, because we need to find the start time that is after our end time. So this is a log n operation. And this is just backward for loop for n.
Yeah.
DP table is also n.
Yeah.
I think it was all right speed. Yeah, it was all right. I'm not sure if O of n is possible because we have to sort also. We sorted as well.
Yeah, we always, either you sort it on end time or start time. So start time, so it will always be at least n log n and more than that. Yeah, but that's good. And you are using a binary search there also and an knapsack way. So he has covered almost all of the scenarios, right?
Yeah.
That's good. Yeah, no problem. Thank you. Yeah.
Thank you very much. Thank you.
Yeah, thank you. So so Shashank, you want to go with your approach?
Yeah, mine is like a prefix one, like just reverse of what he's doing. It's almost based on the same concept. So he was sorting based on the start time, but I'm sorting based on the end time.
Okay.
I mean, X1 I'm taking, and then I'm storing all the end times in my array. And this is your number of jobs, and I'm creating a DP array of filling everything with 0 and such jobs. And now initially it will be whatever, I mean, for the first job, it will be whatever you have the value, right? Because we are not comparing. Now from 1 to n, I'm going. So the start for every, what do you say, start and then profit I'm taking. Now these are the two cases. If I don't schedule my current job, then I take the previous, whatever profit I have, the same will be carried to the next. But if I include my current job, then he was taking the lower bound there, right? But I'm taking the upper bound here. And for that upper bound, I'm just checking the current one. If I schedule it, what will be the, what you say?
Yeah, because you're storing there, right? Yeah.
Yeah. And if not, then profit plus this I'm just checking because it's upper bound. If it hits a negative, then we'll take it as 0. Otherwise, yeah. It's a prefix DP, then you can say.
So you actually on line 13 when you are initializing with I minus 1. So that is where you are skipping, correct?
Yeah, skipping previous value it's taking for the current one also.
Okay.
Yeah, I'm not sure taking the current job. Yeah.
Yeah. So DP of index. So index will be in this case, it will be the remaining in the previous one, right?
Previous one, yeah.
Okay. And then the profit is what you are adding at the end, which is P, the current one.
Plus P, yeah.
Yeah, makes sense. Yeah.
And the last value I'm returning.
Right.
DP of my.
Yeah. So these both are almost similar, right? But it's only the prefix and
yeah.
suffix way.
Yeah.
Yeah.
Let's see. And line number, can you explain line 15 again? Why we need to do binary search?
Just we are let's say you got this job, right? I mean, let's say you finished up to 3. Now you want to take this job, 3 to 6 you want to take. So whatever value you have here, how will you take the previous one? You'll take only that job whose end index is less than the end index of the current. The start of the first this one, right?
Yeah. So you are actually doing a comparison on the start time, right, of the current job.
Current job.
And then from the end times, which is a sorted array based on the end time. So you are trying to find out the start time. In the end times, you are trying to find out which is bigger than.
So you finished the job. Now you want to start the next job as soon as possible.
Yeah. So it's like you have 0, 1, 2, 3, 4, and then 5. Like let's say here one job was there, I finished it. So what I'll take the next upper bound of it, right, to start the next job. So what is the start time of it? That it will be taken by this bisect, right?
Yeah, but you will find that start time value in your end times sorted array.
Array. Yeah, this one.
Right.
Yeah. Okay. Makes sense. So you are looking forward way. Okay. Yeah.
Forward. Yeah. And he was going back way. I mean, the other way around. Lower bound he was checking, right? I mean, here before.
Yes, mine was sorted based on start time. So I
Start time.
Yeah, but these are difficult algorithms to come in an interview, correct?
Yeah. It's like under those standard that we are doing every Sunday. No, it will fall one different category. Looks like under knapsack, but it's not under the knapsack. Wait, job scheduling is a different, section itself.
Okay. So you'll have to remember this pattern very well, right?
Exactly.
Okay. Either you stick to the suffix way or prefix way. If you're good, you can stick to both of them, no doubt. But you at least have to master on one of them.
Correct. So basically the suffix way, if you are doing, then you have to do DP on the start time, since you are sorted by start times. But it's sorted on end times. So you're doing DP on end time. So each moment you can check for the I-1, since you have the previous end time. You're filling from left to right.
Correct. Yeah.
This is standard sorting on times, right? In every merge intervals, like we do.
Yeah. Because, initially when I saw this problem, I started thinking in the interval way.
Okay.
I said, okay, profit might be just one attribute to the whole system. So I'll just go the interval way and see if my overlapping thing works or not. So I was totally only in that brute force way. I could not actually proceed ahead. But then, as you guys have said, we'll have to go for a different pattern altogether. Then only is going to pass the time complexity of Leetcode also, right? Also,
actually, this was mentioned in the hints. I read the hint. They said that see the suffix DP. Hint number 1, 2, 3.
Yeah.
Yeah, but now we have all these hints that that's good. But then in an interview, we won't have this. We'll just have a problem, right? So how to come up with, we are just trying to understand, so the best way and the quickest way. Yeah. So anyway, we'll have to actually be good about this pattern, right?
The wait job scheduling. Yeah. It's a separate section completely.
Even with the hint, it's still not, easy to come up.
Yeah, I mean,
because you have to think in terms of like.
There is another way. I mean,
Yes, but when they tell us what is the DP, then we have to just find out the relation. Like they said, define DP as maximum starting at I. So then it was about just finding that relation.
No, yeah.
Yeah.
Yeah, Uday, you had something to say?
I mean, this can be solved without DP as well.
Mm-hmm.
So actually, if you think of this problem, it is like an LIS or similar kind of problems.
Uh-huh.
So actually, this can be translated like this. So you can keep, I mean, uh, so at the end values, you can keep a value associated to that index. So you can keep a value of 20 at 3 and 20 at 5 and 70 at 6 kind of no, so 90 at 6. So I was actually thinking of it as I mean segmentary kind of approach. So when you actually sort this by n times or start times, but whenever you take the current interval, you let's say the let's take example 2 itself, and for the profit equal to 60, I will try to check what is the range maximum till 6th index.
Okay, in the previous section.
Yeah. So that would come out to be 90. I mean, I'm guessing. Similarly, if you take for profit equal to 70, what is the maximum profit till 4? That would come out to be 20.
Okay, so you do a range query prior to that start
Yeah,
element.
range maximum.
Oh, range maximum query. Yeah. Okay. RMQ. Huh. That's interesting.
What? But in your segment tree, how would you determine like not to take when the ranges overlap, you don't take it?
No. So initially, all the indexes are initialized to 0. So I will try to explain for example 2. So initially we would take for the first profit equal to 20. Now you do a segment query with what is the maximum value till 1, that is 0. So you initialize 3 to 20. Next profit equal to 20 comes in. Then you do a range query till 2, 0 to 2. What is the maximum value till 0 to 2? That is 0. So you do 0 plus 20 and initialize that value at 5. Now you get the profit equal to 70. So that is starting at 4. Now you do a range query. What is the maximum value ending at 4? That would come out to be 20. So so 20 plus 70, 90, and you initialize that at 6. Now you do range query for the profit equal to 60. So what is the maximum till 6? That would come out to be 90. So 90 plus 60, 150. So you will initialize the value at 9 as 150. Now the 10 comes into picture, and now you do a range query from 0 to 3. 0 to 3 is 20. So 100 plus 120, 120. 100 plus 20, 120, you initialize at 10.
Okay. So you build a segment tree as you go.
Yeah.
And then how do you find the max? So that will automatically come to the root, right?
You are providing that interval, right? From this interval, what is the maximum value?
Oh, okay. So from 1 to 10, it will always be in the way it is said, 150. Okay.
Yeah. After this is constructed, I mean, the top value would be the maximum value.
Okay. Huh. So what will be the time complexity of segment reconstruction and the query also? It will be
Log n.
log n, right?
Yeah.
Only
Total would
n
be
log
log n.
should be log n only.
No,
Yeah.
querying will be login, but constructing the whole thing, it should be n login, right? Yeah.
Yeah.
You construct one at a time, and then yeah, at the end no, it's still log n.
You can
Mm. Yeah, that's good.
actually values, right? So initially all the values are zeros itself. So you can construct on demand as well.
Okay. This,
If I haven't written the code, I will share it today.
yeah, please. Yeah.
So
So at least it will be often, right? Every element you are visiting, and then whenever you find end time.
actually no, because for the first itself, you can actually create one. Instead of creating, so generally you visualize
Your voice is
really, no, I was actually saying you can generally you view segment tree as an array, right?
yeah. For an array.
But you can visualize it as a binary tree itself to construct on demand. So you will just construct the whole range as one root node itself, and as uh, on demand, whenever intervals are coming, you can insert those.
On the
Okay.
It's
Okay.
a nice way to solve it.
Yeah.
Optimize highly. More
So
than this.
segment tree applies, this pattern applies to many places, correct?
Yeah.
Okay. Very good.
Actually, I'm not. Might be. If we, there might be way of that LIS extensions as well. Maybe I'm not sure.
So if you're talking about LIS extension, so then what basis you are considering LIS based on start time or end time? Right. So it will be sort of bucket sorting. Okay.
Maybe end time itself, because we are. It depends upon whether we are taking the prefix or suffix approach.
Okay.
If you are going from the left, you might take it at the end values.
Okay.
Heaps we forgot to discuss.
Yeah. So that's good. Like we have an LIS extension or the segment tree approach.
A heap is also there, but
Oh, there is one more. Okay.
that's a standard one DP with BFI research.
Probably with heap, they don't need to do the binary search, the second binary search. I mean the binary search to find the next job.
No, that max heap will give you, right? 2 heaps again they are using, I think. Yeah. The top of each of the heap will give you the next.
Wait, heap may reduce the runtime complexity, right? Yeah.
I don't think so. We will get much better. Most of them will come
Log
to
in
the
only.
same,
So this
right? Yeah, that's n login. So we won't be able to get much
It is
better.
also sorting only, right?
The only thing is solving this problem with any pattern should be fine. Yeah. Yeah. But Uday, when you're done with your segment tree approach, will you please share it?
I will share it back again.
Sure. Yeah. Anytime.
Yeah. So we can move to next, right?
Yeah.
Yeah.
Okay.
That's what
So restore the IP address. So string s is given, consists of only digits, and return all the valid IP. And the definition is like valid IP will have 4 integers, exactly 4, and they will be between 0 to 255, separated by single dot, and cannot have leading zeros. Yeah. So this is not a valid one because dot after 0 is there. At the rate, special symbols are not allowed. So these are the 2 possible ways to split this into our IP.
So when you have a 0, you can have it a single section or a.
Yeah, normal 0 is allowed. Only 1 0 at the, in 1 byte. We have 8 bits of that, right? Every slot, 32 bit.
So yeah,
Correct.
first digit is allowed as a bit, only one digit, but not a trailing one. Sorry, a
Leading.
prefix one. Yeah, leading one. Yeah.
So if you have string of 50, would it be okay? Because one of them can have 20.
No,
Let's
that's
look
also
at
not allowed.
example 2.
Not
Let's
allowed.
That's not
scroll
allowed.
up a little bit. Oh, yeah, right there. No, I mean, look at example 2. You have 50.
No, they
4
are
0.
four actually.
4.
Yeah,
I'll find it.
example, you have 50. Would that still a valid one?
No,
Because
I
in
think
one
that will
place you
be.
have to put 20.
No, that's not allowed. No, because again, leading 1 0 will be leading in that case. 5 0 won't be a valid one.
Yeah,
Okay.
that would be an invalid test case altogether. It will return empty. Yeah. Okay.
And secondly, what do you say? Odd number will always be invalid one only, right? And
What do you mean by odd?
or like the length of a string is odd, it will be invalid. No, I think that's a wrong inference, right?
Oh no. Yeah, it can be, because maximum size of a digit, you can go for 3 max digits, right? So 3
Yeah.
into 4 will be 12. So if it is more than 12, then that might be a
Invalid one.
invalid case. Yeah.
Okay. Yeah. It's again like exhaustive search you do, right? Kind of backtracking.
But I might be wrong, because if you look at the constraints,
Okay.
they have given the length s to be 3000.
Which is odd. Yeah.
So I don't know, maybe. So the
No, this
one
is
as
string only, right?
if
3000
you
is.
have all 0 0 0s, right? Many
Yeah.
zeros or something like that.
Actually, we are just placing 3 dots in the middle of the string and then checking if it's valid in an ultimate brute force. So it should pass.
Yeah. Go ahead.
Come again, what was that?
So I think we are just placing 3 dots in the middle of the string. So it's like n cube. So it should pass even in a brute force without any validation in the middle.
Yeah, length is not that. I mean, 10 raised to the power 3. So it will be 10 raised to the power 9. It will pass, yeah.
Oh, yes, it might.
Length. Well, yeah. So they are we saying that the max length is supposed to be 12, but this one is 3000?
Yeah, so I am also not
So
very clear
let's
why
try
it is
to
like that.
put the whole bunch of 0 in front of example. Can you scroll up a little bit, Sachin?
Which one?
Yeah, right there. Put example 3. If we put a whole bunch of 0, leading 0 in front of it, is that when after parsing it's still like 1 1 1 1?
Okay. So you're saying put a zero is about how many? 5, 10, something like that?
Yeah.
Okay. And you want all those 4 ones, right?
Yeah. The 1 1 1
1,
1.
2, 3, 4. Okay. Let me try it here. Okay. Yeah, it gives an empty results because it is not considering all those leading zeros. So that becomes invalid. Invalid in the sense it doesn't say anything. It returns a value empty. So it accepts that string value, but it just returns empty value. Or else Leetcode will always say it's an invalid test case, something like that, right? Yeah. Okay. So you just accept it and return empty. That's all. Okay, no problem. So okay, how do we go about this?
So again, same like first you take. I mean, we will have only 3 branches, right? 1, 2, then other will be 2, 5, and then if for the first example I'm talking, let's say this, because more than 3 you can't do, right? Because it will exceed here or 255. So again, we explore these branches, and every time you do this, you just check it whether it falls between 0 to 255 or not.
Okay.
Now further you can't go to this branch, right? Because it's already done. So you can revoke this and again go with the another character over here. No, no, we can't revoke that, right? Because
yeah,
we can't skip any
2,
character.
255, and then the next one will be 255 again. The next one will be similar like this, right? The second branch.
Yeah, this 2, then 5 we can add here, then 255. Yeah, I mean something like that, right?
Yeah, that is what sort of a backtracking you're
Backtracking, yeah.
trying to come to, right? Okay.
Type the brute force.
Brute force, 4 loops you use, 3 loops at least. For each loop we'll take one number and then try to put a dot and check whether that is a valid or not. N-cube. What Johan was saying.
Okay, yeah. What you were saying that you go through. So it might be n-cube in that case, right?
Yeah.
But still, that might also pass. That is what you were saying. Correct.
Yeah, it will pass because 10 raised to power 3 is only the length. So 9 at max it will have.
Okay.
And we can somehow with continue and break statements, we can include backtracking into that solution as well. I think so.
Yeah. So yeah, if we use a backtracking, then that would be optimized way of doing it, right?
Yeah, we are pruning some of the branches. Yeah.
But in the iterative approach, since we know that each of the digits, the maximum number of digits before one period can be only 3. So we can iterate only thrice. That can reduce the complexity.
Can you come again?
Before the first period, we know that only at max 3 digits is possible. So we need to iterate only for the before the first period, we know that we only need 3 digits. So we will iterate only 3 times. Again, before the second period, we know that only 3 digits will at max exist. So we will iterate only thrice. Same for third, same for fourth.
Correct. Yeah.
In that case, yes, in that case, the complexity will not go to n-cube, since we are iterating only thrice for each of the digits.
But on each of the 3, inside we are again going 3 times.
Yeah, but you.
So 3 raised to 3 maybe something
it will
like
be
3.
like pseudo linear, I guess.
Yeah, it would be like n square, and then for the innermost loop, it's going to be only 3 or 4 times max, right? So that will be almost constant.
So it will.
Yes, in my inner loop, I'm just checking 2 values if they are both less than 2.
Pseudo quadratic or pseudo linear.
Could you annotate it? I don't get it.
So I just wrote 3 for loops and I just checked all the numbers. Any moment the number is greater than 255, I just write a break statement.
Okay, share it. Let's see.
I can share?
Yeah, sure. Go ahead.
Abhishek, you also free.
Yeah,
whatever you're saying there.
So I said that we just want to place the dots. So first dot we are calling I. After placing this dot I can be placed only in the first 3 positions. So 0, 1, 2. A is just I'm saying that A dot B dot C dot D. It's the same question.
Yeah, it's a binary search. Yeah.
A dot B dot C dot D. So I took A. A is basically up to the first dot. This is the Python slice. And then if this A is greater than 255, then you want to break. So this is similar to backtracking. It's like early return or whatever, that short circuit. Now the next dot. Next dot will be placed again in 3 positions from here. So +1, +2, +3. So again for this dot I have 3 positions. I take the value of B. Now again if B is too big, then I break. Or This is just my fancy way of saying leading zero, leading zero. So if the string format is not equal to this substring, that means there's some leading zero. We converted it to integer, so the leading zero got deleted, and then we are again checking if it is equal. Basically, this condition is just checking leading zero. And if there's a leading zero, then again break. Now final for loop. Again, this I think we can do 3 dots only. I just put all the dots. Now if I place a dot over here, so all the position from j to k is integer c, and all the position from k to end is integer d. Here, if the integer is too big, I just continue and I try to place the dot in the next position. And then I just return the result at the end, like simply like that only. So I wrote this like little explanation. I'm basically placing I, then I'm placing j, then I'm placing k. This is forming 4 numbers from the 3 for loops of I, j, k, a, b, c, d. So now if any time the condition is false, so I need to backtrack. So what I written in my code is just the break statement for the condition is false, leading 0 or 255. I think, yeah, is it all right? I have mentioned O of 1 since here they didn't give that constraint of 10 raised to 4. But yeah, I'm not sure about this time complexity.
It looks like sliding window, right? Kind of. No.
Maybe in a way you can think that this is just 3 nested for loops for each dot. And yeah, A's window is getting bigger whenever I move J, B, K. I don't know if it's sliding window.
Yeah, but it's very optimized. Yeah.
Yeah.
Yeah,
That's a good one.
it's, I think, optimal solution according to
Because every time you're, I mean, one index shifted, the other side also it will go ahead by one. So sliding looks like not exactly, but somewhat gives a sense of feeling like that.
maybe for the final dot, because that one dot decides both C and D.
Yeah.
Oh,
This is cool.
yeah.
Yeah, will you share this code in our Discord if you're fine?
Of course, yes.
Yeah.
I'll share everything or just the code.
Yeah, you can share anything, no problem.
Okay, I'll share
You
it.
can share this link also. Yeah, the binary source, right? Okay. Good. Yeah. So yeah, Abhishek, what was your take on that? You had some different opinion, right?
Yeah. Shall I share my screen?
Sure. Go ahead.
All right. So is it visible?
Yeah.
Okay. So first I wrote a function which checks if one of the string before the period is valid or not. So for example, if the string comes out to be 257 or 259, then the final answer must return false.
Okay.
So this is a Boolean function which checks if uh, one of the 4 string is valid or not. So first of all, the length should be less than 3. Then if the length is greater than 1 and the leading one is 0, then again it will be false, since we know that we cannot take strings which comes out to be 01 or 001 or 002. So in that case, we need to return false. Then since it is a string, we cannot compare it directly. So I have used this stoi function in C++, which converts string to integer. And then I compare the value that it lies between 0 and 255. If it lies, then it returns a true value. So this was the first Boolean function to check. Now, when we receive a string, we know that the first dot can be placed after iterating once or iterating twice or after iterating thrice. So at max, the first the first uh, string before the first period can be at max of 3 digits. So we are iterating from 1 to 3, and also we need to check that the size, value of the iterator does not exceed the final size of the string.
Okay.
So this is the first part. Then I have named all the strings as first, second, third, and fourth. So it will be easy for understanding. So the first string will be starting from the 0th index and will have the length I. And the I value is going from 1 to 3, which means we will have a string of length 1, 2, and 3 at max. So after getting the first string, we need to check if it is valid or not. If it is valid, we need to go again and check for the second string. So the second string will start exactly after uh, the point where we choose our first string. So if I chose after 0, then the second string will start from 1. So here what I did was, again, we know that the length of the string can be at max 3. So the iterator goes from 1 to 3, and the point where the first string was closed uh, is given by the ith value. So here again, we will get the second string, which will be uh, exactly after the point where we finished our first string, and at max it can have a length of 3. Again, if the second string is valid, we will go for the third and fourth string. So means if we place if this is, let's suppose this is the first one, this is the second one, and if we place the third period here, then we know that this is the third string and this is the fourth string. So I plus j is determining where the second string was closed, and the value of k determines what will be the length again. So again, it will go from 1 to 3. Each time we are iterating only thrice. So here the loop will go 3 times, again 3, and here again 3. Now we know that the index at which the third string was closed is I plus j plus k. And if we pass in substr method I plus j plus k, then it will take the whole string which was left after taking the third part. Then again we check if both satisfies or not. If it satisfies, then in the final answer we push the string.
Okay.
So
Yeah.
first, second, third, and fourth.
Fourth,
Yeah.
combining, appending them.
Yeah.
Yep. So here we can see that the complexity will be uh, around this constant time complexity.
Yeah, it looks like correct.
Since we are iterating only thrice for the first one, thrice for the second one at max, and thrice for the third one. But when we are choosing the third one, we already know that the fourth one will be the those string which
Remaining.
are left at the last.
Yeah.
Yeah, makes sense. Yeah. So I think it's both of you, like Yuan as well as your, it's slightly on the similar lines, right? Yeah.
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 Putting the check on the another function was very nice. Made it
Yeah.
look very clean.
Yeah. Yeah.
Yes.
Yeah, this simplified everything. The modularization,
Yes, yes.
it simplified illustration so well.
If I am
Awesome.
checking here in the for loop, then it will be very messy. This is why I wrote this check function again.
Awesome.
Different approaches, right? Yeah. Both are good. Yeah. Cool.
But most of the people will skip this case. Even I skipped this one, where the leading zero case, where the
Right.
first digit will be 0 and the length will be greater than 1. This was one of the edge cases in the check function.
Yeah, that's the important one to check. Correct.
Yes.
Why a dot length greater than 1? False.
So if
Okay, only
we are
one.
choosing the string
For
as 0
zero.
1, uh,
Mm-hmm.
0 0 1, then this
Okay.
is this is not valid.
Yeah. That
Yeah.
answer.
It's
Perfect.
1 0 is allowed. Yeah.
How is this approach different than the previous one?
They both are almost similar, right?
Similar?
Which
Yeah,
like
there are
C++.
slight differences, but yeah, both in we have two approaches also. Both have a similar pattern, I would say, not the same, no.
Yeah.
Yeah, good.
Yeah.
All right.
Yeah, thank you. Yeah, yeah, Prashant.
Yeah. So mine is like normal, the typical backtrack that we do.
Okay.
Yeah. So you have a resultant this. You create a DFS function in which you pass the string, the initial index, I mean the intermediate one, the empty string we are passing, which will store intermediate,
Mhm.
and this is the resultant array address. So when you, this is one of the condition, like if your index is greater than 4, you'll return. And if it is 4 and you are at the end of a string, just reverse it and append it to my resultant array and I return from here itself.
Mhm.
Now I'll go for what you say, from 1 to the entire length of a string. I'll just check if if that is ending with 0, if this is the case, or what do you say, if the leading character is not 0 and it lies between whatever string you have chopped, if it lies between 0 to 256, then you are valid, good to go for the next call. So for the next call, it's like till I we have done from I onwards to the entire length of a string. We increase the index, and whatever we chopped for the previous one, we are appending to the path. Path is like a string, the intermediate result storing, and dot is like the way we have to return the answer by putting the dot in. This is a parameter s. So this is your main, what do you say, base condition, and this is like the intermediate condition, the leading zeros and should be within 0 to 55,
Right.
656. Yeah. Go for the next one. Yeah.
So
I
this is like I would also come up with a similar backtracking only.
We are used to this. Yeah.
Right, right, yeah.
That's yeah.
That's good one.
But I think those two, the Abhishek and Johan, what said were more optimized. It's like
Yeah, they are a very different way of thinking. Yeah, that's good. But in case if we are not able to come, so at least we should be able to come with the
this.
backtracking approach, right?
recursion. Huh?
Yeah, the recursion. Yeah.
So
So
every
also,
time you call the DFS, you pass in kind of a new string, right?
yeah, that I mean, this is like till I and after I. I dot is after I onwards. And then again we run an index plus one.
Let's see.
Yeah, that's good too. Yeah.
Yeah.
Cool.
So shall we move to next, or
Did we talk about the runtime complexity?
Yeah.
for my
Yeah.
So what do you think
oh,
in this case?
one for loop is there, and at max entire string will be divided into 4 parts only, right? 4 dots will be only there. So
Well, okay. So is it not still going to be only whatever the number of digits what we have? We are not going to, okay. Are we going back and forth? No, right? It's
no, back up because we are removing those many strings once it is done
Mhm.
for the next call.
I guess in the line 13, where you are using len of string plus 1, it
Yeah.
can be made 3. Since we, no, it will be 4 in Python. Since we know that we have to iterate only 3 times at max.
Yeah.
So it can be minimum of 4
four
comma
or
len
three.
of
Yeah,
s
yeah,
plus 1.
right. Yeah. So if
If
we add that check, correct? Yeah.
yeah, if we don't do that, then for four of the all the 4 strings, we will be iterating for the whole string. So
Especially in
again,
case
it
of
will be
like
n to the power 4.
the string length is 3,000, right? You still need to go through all the way to 3,000.
No, but that will be a base case. That will be handled in the base case, right? On line 10, he's actually checking if IDX is equal to 4.
And you are
Because,
overstaying.
yeah, if he's going more than that, he'll come back in the recursion, another recursion call, and then he'll look for IDX 4. And if it is not, because if it is greater than 4 on line 8, he's returning. So he's pruning that, but yeah, we could do it earlier also. Right, yeah.
Yeah, but then I think because it also check like we were saying, like if it trail only 12 character, I mean 12 digits is maximum, right? But this one, if it, let's say the length is 3000, it still keep going.
No, it will come at line 8 again at the end also, because if you have consumed all the first three, whatever the sections of the digits, and when you come out the last four, which will be the remaining string of maybe like 1000 or so, it will come here and look, if my IDX is greater than 4, it is going to return from there.
Yeah, but that still need to go on each index, beyond 12.
But your IDX will be here, right, in that case?
Yeah, should.
Yeah,
Or you
because
don't
on
compare with
line,
the 4, right?
in line 13, even if we are not going for the DFS call again, but even then, in the line 13, the I value will go from 4 to
Oh,
len of
okay.
s plus 1.
Okay,
That
yeah,
is the redundant part.
it will iterate all the way to the end. Correct, yeah, my
Uh,
bad there. So you could prune it there itself then in that case.
yes.
Okay,
So
good.
it will be max of 4 comma len of s plus 1.
Hmm.
Oh, min of max.
Min of 4 or len plus. Yeah, len is good. Yep, that's good.
so if we limit it to 3, then what the runtime complexity?
Then I guess it will be same as the iterative version.
Yeah.
3, 3 cross 3 cross 3 kind of.
Only
I
only we are using a stack call, so the space complexity will increase.
yeah.
And that's an implicit step only. So it's a constant space.
So 3 plus 3 plus 3, we saying that is a constant runtime?
Yeah, that's what it comes to.
3 into
But
3
max it can be linear in the worst
Yeah.
case. In this case, what it's showing here, right? Yeah.
Yes.
Okay.
Since we are slicing the string, that will be, I guess, linear one.
Yeah.
Okay. Yeah.
Yeah. Good. No problem. Thank you, Shashank. Yeah.
Yeah. So next we can go then.
Yeah.
Yeah. So powerful integers. So two positive integers are given, and if it is powerful, then this equation should be satisfied for every I greater than 0 and j greater than 0. You need to return the list of all powerful integers that have values less than equal to the bound. Return answer in any order, and each value should occur at most once. So is trying from 2 to, x is 2, y is 3, bound is 10. So for 0, all the possible combinations is doing, right? Wherever your bound can be less than 10. So these many other values. 2, 3, 4, 5, 6, 7, 8, 9, 10. First 2, right? 0, 0, 1, 0, then 0, 0, 1, 1, 2, 1, 3, 0.
What
Yeah.
the constraint? Can x be 0? Oh,
No.
okay. 1. Okay. 1 to 100.
Yeah. And bound is. So x can never be 0. 0 to the power anything, it's not defined in maths, I think.
Right.
Yeah. So yeah.
Okay. So how do we go about this one?
One is, yeah, go ahead.
So we can make two assumptions, right? The first assumption is if you look at the constraint, one of the constraint is our bound. Our bound is less than or equal to 1 million, right? And the second assumption is, so since we're taking x to the power I plus y to the power j equals to bound, if x to the power I is already a bound, then we don't need to check for y to the power j, right?
Mm-hmm.
That's the
Yeah.
other assumption we can make. So I did it with a double for loop, where basically my first for loop is taking in if I is 0, right, and I is less than 20. I'll explain you how this 20 comes in. I is less than 20 and power
You can
and mhm,
share the screen. I think it will be better to explain
okay,
more.
okay.
Yeah.
All right. So So the way I did it was, all right, so we will use set because, when we add stuff to set, it get rid of the duplicates and we can return our non-duplicates values. So I got my set first. The first for loop is taken for int I equals to 0, right? Because that's where I starts. I is greater than equal to 0. I is less than 20. I'll explain the 20 in a little bit, but and math.power x at I. So basically, this is the bound I was talking about, right? So if this is or so this cannot exceed bound. If it's already exceeding bound, then we don't need to check this, because remember our sum needs to be equals to bound. So that's why it's checking if method pow act if one of the bound is less than bound I plus plus, and go to the next one, j equals to 0, j is less than 20, math.pow, and now check the other bound. If it's also, it has to be less than our bound, and then the increment, right? And then we're checking, okay, now give me the sum. This is the sum is checking in, right? Math.pow. And since the math function in Java, it returns as a double, I have to cast as an int, and then I get my sum, and then I check, okay, if my sum is less than or equal to bound, then add it to my set at the end. Make a new array list. It has a constructor where we can allow set, because set is part of collection interface, and pull that in and return our result as an array list, and that's exactly what it does. It says new array list, pass in my set, give me an array list. Now the question comes in, where this 20 comes into play, right? This magic number. It took me a while to understand, but so basically how that 20 comes in is, if you look, right? So all right, so I is greater than equal to 0, j is greater than equal to 0, okay? Now if you scroll down, what's our bound? Bound is 1 million, which also means that let's say if I make one of my, because now the question comes, how far am I incrementing I on j, right? I know I have to increment, but I can only increment up to so far. Now let's say, to find out, let's say if I convert, let's say if one of the x and I or y to the power j is 1, right? If I say one of them is 1, because anything power to the 0 is 1, and it starts with 0. Like one of them, let's say it's a 1, which means, now let's say if this is 1, so x to the power I plus 1 has to be less than or equal to 1 million, right? Now we can't check for, I can't say x as in 1, because anything to the power 1, 1 to the power anything, is 1. So I'll have to start with 2. I'm going with the lowest. Now, if we do the math, let's say, let me do a comment here.
In log, you are taking both the sides after that, I think.
Right. So this is what it comes out to, right? So we're saying, okay, 2 to the power I is less than or equal to million, right? Now, if I do 2 to the power 20, right? If I do the 2 to the power 20 plus 1, right? This is so
I
this
think 2 to the power 20 is 2048.
exactly. So now actually 2 to the power 20 is, this is what it comes out to. 1048 5. This is high because what's our bound is a million, and this is going over a million. Now we need to stay less than a million. Now if I say 2 to the power 19 is okay, then this to the plus 1, right, is, which is less than million, right? So that means my I and j is 19, is cannot increment over 19. And that's why we're checking by increment I and j up to 20. Less than 20, it means it goes up to 19. And that's where that number 20 comes into play.
No, approximation.
Exactly. Yeah, because this math right here. So 2 to the power 20, it goes over a million. Look at this, 1048, right? 2 to the power 19 stays less than a million if we add 1 to it. And that's why we're incrementing up to 20. And yeah.
Makes sense. Yeah.
So let's say you have x equal 1. I mean x equal 1 and y equal 1. Would that 20 is that 2 to the 20? How does it exceed the bound?
Because what is 2 to the power 20? 2 to the power 20 is 1048 So if he lives
I
to the
mean,
max,
like if the input x equal 1 and y equal 1, right? Then
So in that case, that power won't matter, right? If it is 1.
Yeah, both are x plus y. It will
So
be.
both are 1.
After 20 iterations, the loop will exit.
exactly, because
Yeah.
it's 1, 0, 4, 5, 7, 6.
Correct. Yeah.
So yeah.
That makes sense. Yeah.
It's a
That is
good one.
good. Yeah. That's very good observation.
Now, one thing I'm still confused on this is the time complexity of log of 2 bound. I couldn't quite get that. I don't know if any of you guys.
It's constant only 20 cross 20, right?
Yeah, 400.
400, yeah, constant it will be.
Looks
The
like.
interesting thing is if we don't
But
set I less than 20, then we
Uh-huh.
get an infinite loop because
Yeah.
1 raised to 1, 1 raised to 2, 1 raised to 3, 1 raised to 4, all are 1 only.
Yeah.
yeah. Can you come back to my question? If x equal 1, y equal 1, what would be the answer? What would be the output?
Correct. So I made some hard coding, like if it is 1, then don't go in a loop. I don't know about others.
So if x is 1, y is 1, what's my I and j? Depending on what my I and j, that's what my answer is. Right.
Yeah.
So no matter what, the answer will always be 2. So you can just directly return 2.
Yeah, you can, I
Yeah.
mean, you can avoid the loops. Like, because we know anything to the power
Okay.
of 1 is always 1.
Yeah, okay, I see. You have set right there.
Right.
That,
Right.
that remove duplicate.
Exactly. Yeah. So this is my sets. The only reason sets there, so I don't need any duplicates, right?
Mm.
Yeah.
Hmm.
Yeah.
It's a very neat way of coming. Yeah. That's cool. Yeah. Yeah.
Uh,
So it's the 20 was a very good idea. Yeah.
Exactly.
Hmm.
Yeah, even the
To calculate.
solution says 18, and I didn't quite get it. And then once I understood that's math, and this is how 20 came into play, and then I was like, okay, now I got it. But
18
even
to
the
the
solution says,
sense,
yeah.
18, it is like 0 to 18. So maximum it was 19, right?
Hmm.
No, it
Because
cannot be.
So we said we can go up to 19 because our bound is million. So as long as we're within the million, we're good. Yeah.
so you are also not going to 20, you are going to 19 only, right?
Yeah. I'm only saying
Same.
it's less than 20. Yeah. See that? Yeah.
It is also 20. 0 to 19 is 20 only. Yeah.
Yeah.
And then he might be using equal to, okay, no, I don't. Yeah. Maybe some approximation. Something. That won't affect much, right? 18. Okay.
It might fail few of the test cases, so that's about it. Yeah.
No.
All right. I'm
Yeah,
gonna
this is good.
stop my share.
The way you do it, Safa, when you print it, let's say if you don't use the set, for example, you don't use the set. When you print it out, the output is in the order, or the output like it not in the order? I mean, like in the increase. I know the answer would say you can return in any order, but when you print it out, the output will be in the increasing order?
No, I don't think so because we're using Haset and Haset doesn't store in order. If I use a tree set, then maybe, yeah.
No, let's say suppose you use the array.
Uh-huh.
Would that be in the order?
But then
I'm
there will
just
be
trying to say
duplicates, right?
this way, we do this way, the output will be, in the increasing order.
No, but how will you avoid duplicates?
Yeah.
Yeah.
Trade-off there, yeah.
Yeah.
Yeah, quick way to do. Yeah, use a hash set. Yeah, that's true.
Yeah.
Or then tree set order and duplicate both will be preserved.
Yeah.
Okay.
It's cool.
All right, I'm gonna stop my share.
Yeah, thanks, Apple. Yeah.
Yep, no worries.
Yeah, I think Safal, we can also have like little, tight upper bound on I and j. Like a could be max log of bound base x, and the j could be like log of bound base y. So that's why I think the complexity you're saying that it would be log of b, log of bound base x into log of b instead of every time going to 20.
I see. That's why they're saying log of 2 bound
Yeah.
on the solution.
Yeah. So instead of 20, you can calculate every time that thing, and then like 20 could be the worst case, but you can,
Right.
you can have tight upper bound.
Exactly. Yeah, because it's a bind to our bound, whatever we set our bound. Yeah.
Mhm.
Okay. Thank you.
So what was that log bound? Sorry, I didn't.
He's using actually math.pow, right?
Uh-huh.
So I mean, I less than math.pow, something let's say 2 raised to the power h. So if you take it in a log version, log I base 2 is equal to x. So time complexity of this reduces to log factor.
Okay. So you take that for the bound. Okay.
Wow, yeah.
Okay. Yeah. That makes
And
sense.
Anything
Good.
so what I was saying, like, yeah, but instead of like you already have x and y, so you know that like assuming y in minimum value y could be 1, but let's say that is even 0 also. So you have x to the power I less than equal to your bound, right? Then take log and then you calculate maximum value of I. That's what I was referring.
Yeah,
Okay.
so that log factor comes from here because of power only, right? Math.pow, what he was doing here. Right?
Yeah.
Mhm. Okay. Good.
So other is like just use a stack, and I just going through the solution there. I saw they're using. I mean, tuple of values are passed, and both the values I'm popping and just evaluating this equation. It's a what is a brute force only kind of. And if it is less than the bound, you add it to your result, right?
Mhm.
And as long, I mean, definitely if the power is greater than 1, then only if x is greater than 1, then only we again increase the value of that I and push the j, and for y we do this.
Interesting. That's as a different way of doing it.
Yeah,
Yeah.
space of taking it is kind of.
Right. Right. So then you were actually doing for on line 7 for X and Y. Okay.
Yeah.
And then that is
It
what
is
you have already popped in.
skipping that case, x equal to 1 and y equal to 1. This line 10 and line 12.
It will avoid that here.
That's good too. Yeah.
Yeah.
If it 1 1, then it wouldn't exceed the upper. If it x equal 1 and y equal 1, wouldn't that the
It won't enter.
statement not gonna go there, right?
Yeah, it won't
Try
enter
to see
here.
where it terminate if x equal 1 and y equal 1.
Oh, where it will terminate. I think that I mean the last call, the last element in the stack at that point
No,
of
it
time.
pop out. Yeah. Okay. Yeah.
Because it
Whenever
won't
go
be
there, the stack not growing. Okay. Got it. Yeah.
yeah, it won't grow indefinitely.
This is a good one. Yeah. It's a totally different one. Yeah.
Yeah.
Good. Yeah.
Yeah,
Thank you.
sure.
Thank you, guys.
Thank you. I'll stop the recording.